Hi, I'm Chris Hadfield, one of 7 Canadians who've flown in space. I'm also the first Canadian to operate the Canadarm, and the only Canadian to go inside the Russian space station Mir. But I'm the lucky one. My experiences are possible because of the tireless work of 3 generations of Canadians. On March 1st, the Canadian Space Agency will be 10 years old, something we'll be celebrating here at the CSA headquarters in Saint-Hubert, Quebec. But our history in space is much longer than that, and tonight we're going to tell you all about it. We'll begin on a fall day, 37 years ago, when Canada became the 3rd spacefaring nation on Earth.
September 29, 1962. At Vandenberg Air Force Base, California, a team of Canadian engineers and scientists anxiously await the liftoff of an American rocket. On top of tons of highly explosive rocket fuel is the focus of their attention, Alouette 1, Canada's first satellite. The Canadians do not know it yet, but their American hosts have private doubts. NASA has no plans to use the data from the Canadian satellite. Some of their experts think Alouette will fail an hour after launch. So, as the countdown nears its end, the future of Canada's fledgling space program is on the line. But if everything goes well, Canada will be the 3rd nation to have a satellite in orbit. 5 years earlier, in 1957, the Soviet Union became the first nation in space. Sputnik's beeping signal shocked the United States and kicked off the space race. In 1958, the USA became the 2nd spacefaring nation with the launch of its first satellite, Explorer 1. In that same year, NASA invited its allies to build scientific satellites to be launched on American rockets. Seeing the opportunity to begin a Canadian space program, our scientists put together a proposal for a high-tech satellite. It was named after the French-Canadian folk song called Alouette, or in English, the Lark. Its mission would be to study the ionosphere, an electrically charged layer of the atmosphere extending from 80 to 1,000 kilometers above the Earth. In a time when communications satellites are still on the drawing board, clouds of free electrons in the ionosphere allow radio signals to bounce back to Earth.
A region important in world communications, because radio waves which do not follow the curve of the Earth can be reflected from the ionosphere. But sometimes great solar storms disturb the region. Radio signals fade and disappear. To forecast such turbulence, sounding stations around the world send constant signals into various layers of the ionosphere and record the echo. But these ionosondes cannot probe beyond the layer of greatest electron density, and more information is needed from above.
The Canadian plan is to build a satellite that will be launched into a near-polar orbit, where it will circle the Earth every 105 minutes. The US-built Thor rocket will lift it part of the way, and then an Agena booster will take it to a permanent orbit over 1,000 kilometers up. The satellite will be spun and separated from the booster, and then its antennas will be deployed. And then Alouette will be ready for a mission the scientists call sounding, or echo surveying of the top side of the ionosphere.
As the sounder moves into range, a command is sent out, and the long antennas transmit a pulsed radio frequency signal to the ionosphere below. At the same time, the pulses are put on a very high frequency signal that will pierce the ionosphere. The sounding signal is reflected, and the echo received by the satellite is transmitted to the ground. The time lag, about 1/100th of a second, giving the height of the ionosphere. Thus, transmitting a continuous signal, pulse and echo 60 times a second, the satellite reports on the top profile of the ionosphere, hour by hour, to telemetry stations around the globe.
It's a very ambitious mission. Alouette will not just transmit and receive signals at one radio frequency. Instead, it will sweep a wide band of the frequency spectrum, similar to the way you can travel from one end of the dial to the other on a car radio. Sweeping through the frequencies will allow scientists to get a picture of how the density of the upper surface of the ionosphere varies from place to place. And that's because the denser the electron cloud, the higher the frequency it reflects. One such picture is called an ionogram. If all goes according to plan, Alouette will transmit hundreds of thousands of them back to Earth. In January 1959, work on Alouette begins at the Defense Research Telecommunications Establishment in Ottawa. A team of young physicists and engineers is assembled. Many of them are still in their 20s, and none have any experience in putting a spacecraft together. They are given a tight schedule, and over the next 3.5 years, they'll work long hours to meet the NASA deadline. Building a compact little satellite with the electronics that will sweep the frequency spectrum is a radical idea. In an age when microelectronics is in its infancy, it's no wonder that NASA scientists are skeptical. But the team is very confident they can do the job. Because Alouette must spin exactly on its axis, the positioning of all the components is crucial. The engineers are delighted to find that Alouette's spin is almost perfect. It's corrected by the placement of small lead weights. The satellite is powered by 6,500 solar cells that will convert the sun's light into electrical power. And to capture all those echoing radio signals, Alouette needs extremely long antennas. So a unique Canadian invention is used. It's called STEM, and that stands for Storable Tubular Extendable Member. It was originally conceived as a retractable tank antenna in World War II. And with STEM technology, rolls of spring steel are stored during launch on tightly wound rolls, just like a carpenter's tape measure. When the rolls unwind, the steel strips wrap together. The antennas are partially deployed in a spin test, but when they are fully extended, 2 of them will measure 45 meters, 150 feet from tip to tip. Because they will bend in Earth gravity, they must be supported when they are fully deployed during a ground test. The satellite is shaken to simulate the vibrations of a rocket ride, spun in a centrifuge to make sure it can stand the G-forces of the launch, and baked in a thermal vacuum chamber that mimics the harsh environment in orbit. And then finally, the 145-kilogram satellite is flown to Vandenberg Air Force Base for the launch. Carefully removed from the plane, brought to the launch pad, and then hoisted up the side of the rocket, placed on the spring that will propel it away from its booster. And finally, enclosed in the rocket's nose cone. Canadians hold their collective breath as the countdown nears its end.
3, 2, 1, lift off.
The launch is perfect, but will the satellite work? Alouette soon beams down signals saying all systems are functioning normally, and its survey of the ionosphere begins. It sends down ionograms that are impressive in their quantity as well as in their quality, and scientists from around the world take notice. In 1965, Alouette 2 is launched, and because its sister satellite was so successful, there are international partners behind the project. In 1969, the 2 Alouettes are followed by Canadian-built ISIS-1 and ISIS-2 in 1971. The ISIS satellites will also survey the ionosphere. From the data sent down by all 4 satellites, over 1,200 scientific papers are published. This is nothing short of a scientific coup for Canada. And out of the Alouette project, a Canadian space program is born. Everything from the Anik communications satellites, to the Canadarm, to the Canadian astronaut program. You can trace all their origins back to Alouette. And what happened to the satellite that was supposed to fail after 1 hour in orbit? Well, it lasted a little longer than that. Canadian engineers actually turned it off, or retired it, after 10 years of faithful service. Today, Alouette is still silently orbiting above the Earth, where it will remain for thousands of years to come.
While Alouette enjoys its retirement in orbit, we've tried to make sure it has plenty of company. Its first companions also studied the ionosphere, an appropriate job for Canadian hardware. You see, the sun's reaction with the ionosphere and the magnetic North Pole causes the northern lights. That's a phenomenon Canadians have studied for more than 150 years. Another fact of Canadian geography drove our next wave of satellites, the need for a small population to keep in touch with each other across a huge stretch of land. The next time out of the gate, Canada sent up communications satellites.
Our initial communications satellite was Anik, Inuit for brother. It was launched on November 9, 1972. Anik marked a number of firsts. It was the first project by the newly formed Telesat Canada, a private company jointly owned by the federal government and Canadian telecommunications companies. And more importantly, it was the first domestic telecommunications satellite in the world. Anik signals were sent down in footprints that covered all of Canada. For the first time, people living in remote areas could get a reliable television and telephone service. Anik 1's success led to a series of satellites that are still used today. In 1976, Canada put Hermes into orbit. This satellite was the first to transmit television signals to a small dish, pioneering a technology that's now becoming commonplace. As with atmospheric observation, Canada became a world leader in communications, basically because of the shape and location of our country. Canada's geography also led to our next venture, Earth observation.
Canada has the longest coastline of any country in the world. And it's very important for us to know what's going on in our oceans around us. And so satellite technology gives us a view that we would not otherwise have.
Our achievements in this field are highlighted by the spectacular success of RadarSat, the most advanced Earth observation satellite anywhere. It was launched in November 1995. RadarSat can take pictures of the Earth's surface through darkness and cloud cover. This is because, as the name implies, it uses radar rather than photographic imaging. The radar signal penetrates clouds and darkness. Since RadarSat doesn't need sunlight to get an image, it can work 24 hours a day in any kind of weather. It covers a lot of ground, too. The Canadian Arctic can be mapped daily, the entire country every 3 days, and the whole planet in 5. This means changes in oceanic conditions, Arctic ice flow density, forest fires, and crop growth can be monitored regularly. The images can be in customers' hands in as quickly as an hour and a half. Like a camera, RadarSat can zoom in for a close-up, spotting objects as small as 10 meters across. This picture is the International South Pole Research Center. It was taken during a groundbreaking mission to get the first full map of the Antarctic. RadarSat was also valuable in mapping the progress of the Red River flood in Manitoba in 1997.
As the flood was progressing over the 2 or 3 weeks, to map the progress and to develop the operation in order to minimize the loss in terms of damage to property, and there was not a single life lost in Manitoba at that time. I'm not suggesting that it was due only to RadarSat, but I think, the Manitoba government and authorities, they were very well prepared, and one of the strategic tools that they had was the RadarSat data.
More than 500 scientific and industrial customers from 44 countries have benefited from RadarSat. This is one hit that's going to have an even better sequel. RadarSat 2 is being prepared for launch in 2001, and it promises to improve on its predecessor in almost every respect. It's smaller, lighter, can take more readings, and is more maneuverable.
The satellite is able to change its orientation to do left and right viewing within 10 minutes. Where RadarSat 1, it was a major mission just to rotate the satellite so that it can look on the other side, which was needed, let's say, to do the Antarctic missions. But now with RadarSat 2, within 10 minutes, we can change the orientation and do an Antarctic mission.
RadarSat 2 isn't the only Canadian satellite preparing for launch. Work has begun on an all-Canadian satellite to study ozone depletion. It goes to orbit in December of 2001. The satellite and all the instruments on it will be built by Canadian industry. This is just another step in Canada's continuing contribution to atmospheric science. Our expertise with satellite technology has drawn the attention of the rest of the world. They've come to Canada not only as customers, but as partners.
We do get a lot of invitations, unsolicited invitations from the international community for participation in their satellite missions. As an example, we have flown 3 missions now with the Japanese. We were actually the first country invited to participate scientifically with the Japanese on a satellite mission.
One piece of Canadian technology is on the Japanese Nozomi satellite heading towards Mars right now. It will look at the interaction between the Sun and the Martian upper atmosphere. Some en route problems have delayed its arrival, but it will be picking up Martian data in 2003. Our satellite program started with curiosity about our own corner of the world and has led to exploration of the corners of the solar system.
And there you have it, a brief look at the path Canada has taken to become a world leader in satellite technology. When we come back, we'll look at another Canadian specialty, the device that established Canada as the leader in space robotics. Hi, I'm Chris Hadfield, and welcome back to a look at Canada's participation in space. Back in 1969, in the afterglow of a successful moon landing, the United States sent out a call to its allies around the world. Bring us ideas. Become a contributor to our new space shuttle program. And Canada's response has become a national icon, recognized across the globe. And it started with a proposal from industry.
Well, I became involved on December 24th, 1973, when the director of my division at the National Research Council handed me a large bundle of documents, invited me to read them over the Christmas holidays and meet with him on January 2nd, 1974 to give him my assessment of the proposal. This was an unsolicited proposal that had come in from an industrial team led by Spar Aerospace that proposed that Canada design and build a Canadarm.
Lindberg recognized immediately that this was a great idea. NASA was quickly convinced as well. Canada's great track record in aerospace technology had established our credibility. Canadian engineers were delighted with the project.
Oh, this was great. It was something that had not been done previously. It was a good piece of technology for Canada to get involved in. This is very, very sophisticated robotics with not only extremely clever and efficient mechanical systems, but also with some astonishing software to control the computers that in turn controlled all of the joints of the arm.
Construction and testing of the 15-meter, 400-kilogram remote manipulator system presented some particular problems. The system would operate in weightlessness, but had to be tested under the full effects of Earth's gravity. Supports were set up to compensate for the weight of the arm and to help simulate microgravity. The arm could move through its full range of motion without being slowed by the forces of friction. The arm was delivered in February 1981, a little more than 7 years after the idea was presented to Dr. Garry Lindberg. It was tested on the second flight of the space shuttle in November of that same year. As much a banner of Canadian achievement as a tool for space research, the Canadarm became an instant symbol for our country.
To see the arm lifting itself out of the cargo bay with the Canada word mark up there at the shoulder where it asked for it to be put, it was really a very great thrill. I guess I got a lump in my throat.
Yes, well, I know exactly where I was. I was doing a live television broadcast, a CBC special sitting next to Knowlton Nash, and as the arm was, the cargo bays were open, of course, for a while, and as the arm was commanded to move for the first time, the television cameras were panned on my face, and it was kind of an interesting moment of truth, because I'm not sure what I would have said or done if the arm hadn't moved, and of course I was quite elated when it did move just as we said it would, and it went through STS-2 and the flight testing in a very fine fashion. So it was quite an exhilarating moment, having put body and soul into such a project for quite a time.
Of course, the arm did work, spectacularly. It's been crucial to many of the shuttle's most visible missions, like the repair of the Hubble Space Telescope and the joining of the first 2 pieces of the International Space Station. The success of Canadarm created many opportunities for Canada in space. It also created the need for a new, more advanced system to service the International Space Station. It will consist of 3 parts: a base for the new arm, the new 17-meter arm itself, and a smaller, two-armed robot. Together, they're called the Mobile Servicing System, or MSS for short.
The larger arm, the station remote manipulator system, is more powerful. So it can actually dock a shuttle fully loaded to space station, and that's about 160,000 kilograms. It will manipulate the large modules, the laboratory, when we attach them to space station. The smaller arm, the dual arm robot, is more dexterous, so it works with smaller objects the size of a microwave oven or a telephone booth. But it does more dexterous tasks like undo some boats or move from within structure to go and reach pieces of equipment.
The robot will be able to do some tasks astronauts would have been expected to do. This means they won't have to do as many spacewalks. The large arm will be able to lift itself off its base and move around the station like an inchworm, allowing it to perform tasks all over the structure. This arm is almost finished, while the smaller robot is still under development at Spar Aerospace. The development of technology like this has put Canada at the forefront of the industry.
We're going to tell you more about the new arm's important role in the construction and maintenance of the International Space Station later. But next, we'll tell you how the Canadarm created even more opportunities for us in space. It actually helped me get my job. It's probably an understatement to say NASA was pleased with the Canadarm. They certainly showed their appreciation quickly. We were invited to fly Canadians on the shuttle as payload specialists performing scientific experiments. And this meant one thing. A new job had been created, Canadian astronaut. It's a job I'd wanted since I was 9 years old. And I wasn't alone.
This was fresh territory for Canadians. Without a spacecraft of our own, we were not able to put people in space. Now there was a chance for one of us to go into the new frontier.
This was long before the formation of the Canadian Space Agency, and things of this sort were referred to an interdepartmental committee on space in Ottawa, and they said, well, look, we'll just not send people along for a joyride. They'll have to do some useful work. Is there anything that can be done? Well, before very long, it was quickly determined that Canadian scientists were champing at the bit for an opportunity to have Canadians do some work on their behalf.
With this in mind, they set out to recruit people with science, engineering, and life sciences backgrounds. And how do you find people like that? With an ad in the newspaper. More than 4,000 people applied. 6 were chosen.
When I first saw basically what amounts to an ad in the newspaper in 1983 looking for Canadian astronauts, I just couldn't believe it. They were actually looking for Canadians to go up into space.
First of all, I was thrilled that Canada was doing this, and secondly, that a lot of the qualifications they were looking for in the applicants were things that I already had under my belt. So I thought, yeah, I've got a chance at this.
It was exciting. You know, it's kind of hard to describe, I guess, when you had something that was a dream job, if you like, for so many years, and all of a sudden you'd been selected into having a chance to actually do that. And in particular, it's a job where you're going out into space.
Along with Marc Garneau, Bob Thirsk, and Bjarni Tryggvason, Roberta Bondar, Steve Maclean, and Ken Money became the original 6 Canadian astronauts. The first to fly was Marc Garneau. On October 5th, 1984, aboard the Shuttle Challenger, Marc went where no Canadian had ever been. 5 Canadian experiments flew with him. Garneau worked on science designed by McGill University, the Department of National Defense, and the National Research Council. Basically, he was doing research to see why people get sick in space. Unfortunately for the experiment, Marc felt fine. Canadians felt pretty good too, seeing one of their own in orbit. We had the same warm feeling in 1992, when Roberta Bondar became the first Canadian woman in space.
When you're representing your country, it tends to be a very, very emotional time in your life, a real high point. I think that's the kind of thing that you remember when you come back from the flight, really more than anything else. You just remember being there as part of an international crew and representing this beautiful country.
Later that year, Steve Maclean went to space. On his flight, he did some early tests on the Canadian Space Vision System, which is now an invaluable tool astronauts use to guide the Canadarm.
What the vision system does, because at the present time that arm is working in the blind, the vision system basically gives eyes to that arm so that it knows exactly where it's going.
Of the original 6 astronauts, 5 eventually went to space. Marc Garneau flew a second time in 1996, followed shortly after that by Bob Thirsk. Bjarni Tryggvason went up in 1997, acting as both payload specialist and lead scientist on his invention MIM, the microgravity vibration isolation mount. Using a plate floating on a magnetic field, MIM isolates experiments from the small vibrations made by machinery on the shuttle. This allows them to experience an improved, near-weightless environment. Ken Money retired from the program to return to scientific research. In 1992, the Canadian Space Agency sent out another call for astronauts. More than 5,000 people applied. 4 were selected, and 3 are still with the program. Dr. David Williams, Julie Payette, and myself.
Even though we're in the forefront of the action, that's what people see when they are watching a space mission unfold, are the astronauts. Actually, the astronauts are the ones that execute the procedures and the operations that are required, but are designed and thought out most of the time by scientists, engineers, technicians, right there on the ground.
I had my chance to fly in 1995. I was the first Canadian to act as a mission specialist, which means I was operating shuttle equipment as well as doing science experiments. I used the Canadarm to put a docking node in place for our rendezvous with Mir, which I had a chance to visit. The latest mission flown by a Canadian was by Dr. David Williams in 1998.
Well, you know, STS-90 was an incredible mission. It was the most complex life science mission we've ever attempted. At NASA, we had 26 experiments selected from over 170 proposals worldwide. The very great honor for me was to be able to do 2 of those experiments, which came from Canadian investigators from York University.
There are now 7 Canadian astronauts. 6 of us have flown, and Julie Payette will make it a clean sweep when she goes into space this May.
It's important to realize that Canada does not decide when these astronauts fly. It's NASA and their programs decides which is the best astronauts to fly on any particular given mission. And they choose Canadian astronauts a lot more than you might think would be our due, if you will. And the reason they do that is because the Canadian astronauts are the best at the particular task or particular mission that is being contemplated. So we have a very strong and good reputation in the quality of our astronauts. No question about it.
Gee, thanks, boss. Of course, not all our time is spent in space or even preparing for a mission. We also have other duties. And part of our job is to promote the space program across Canada. Often we'll talk to students, telling them about our experiences, and we hope that this will encourage them to consider careers in science and technology. Sometimes we even act as television hosts. But a more common job for me is something called a Capcom. That's the only person in mission control who talks directly with the shuttle crew. And Marc Garneau has been a Capcom too. Dave Williams is the head of life sciences at NASA, a very demanding job, and he's studying how our bodies respond to a weightless environment. Bjarni Tryggvason is still working on his microgravity isolation mount, getting it ready for the space station. Those are just a few examples, and as you can see, Canadians are at the forefront of space exploration and science, and we have been for some time. When we come back, we'll see how it all came together under one roof to become the Canadian Space Agency. Canada had already been working in space for 27 years before the Canadian Space Agency was formed. The responsibility for individual programs was scattered across a half-dozen different government departments, and this made it difficult for other countries to work with us, and it made it hard to interact with our partners in the Canadian aerospace industry. The time had come to bring it all together under one roof. The organization was part of a plan that one of Canada's space pioneers laid out more than 2 decades earlier.
This is Dr. John Chapman. He was head of the Alouette program. In 1967, he authored a landmark report detailing the future of Canada in space. He was the one who said Canada should pursue communication satellites to unite our scattered population. He was also the one who said space was a ripe marketplace for Canadian industry.
So you can look through the history of the development of the Canadian space industry, and it stems right from his vision that said, this is going to be a new industry. This is something that Canada needs to be in.
His game plan is still in place today. The new space station arms are made by Spar Aerospace in Ontario. RadarSat 2 is being built and will be operated by McDonnell Detweiler and Associates in British Columbia. The Canadian Space Agency supports their work through funding, technological research, and testing. We operate the David Florida Laboratory in Ottawa, a world-class test center. RadarSat, the Space Vision System, and the space station's mobile servicing system have all been run through their paces here. We also have labs set up here at the CSA headquarters in Saint-Hubert, Quebec. Our robotics lab continues to make advances on our past successes. This work isn't just about space technology. Applications are developed for everyday use. One example is the new Shell Smart Pump being test marketed in the United States.
You pull into a gas station and essentially you don't get out, and there is no server. And the robotic device will identify where your gas cap is. It will open the gas cap. It will fill your car with gas. It will close your gas cap. And they basically have a barcode system where a barcode could be read, which will provide the account, or the payment will be automatically done.
Robotics technology is also used to operate in the hazardous environments inside nuclear facilities, and used to make new, more functional limbs for disabled people. A companion to the robotics projects has been the Canadian Space Vision System. It helps solve some of the trickiest problems of working in space. Because astronauts have a narrow field of view from the shuttle, objects being manipulated are often hard to see. Also, since everything is framed against the harsh blackness of space, it's hard to judge distances. The vision system uses a series of markings on the objects being maneuvered and a variety of camera angles. It then generates a computer image astronauts use to guide the arm. This allows us to judge distances to within millimeters and to make sure everything is positioned at the proper angle. Without this system, much of the work in space would be impossible. Part of the agency's job is to look ahead at future space missions, like trips to Mars, to see what Canadian technology could be developed.
We basically look at the time horizon, what could be coming up, and develop specific technologies so that we can do that mission. It's almost like you can call this a roadmap to a mission, or some people have used the word footsteps leading to a mission. So we are really the footsteps which lead into a mission.
When we come back, we're going to look at footsteps on the moon and some of the Canadians who helped make that possible. So far, we've shown you our progress in space under Canadian leadership, but there's a chapter in the story of Canada's contributions to space exploration you may not be familiar with. It's the story of 30 Canadians who left the country to participate in humanity's greatest adventure. It's also a story that begins with a sad moment in Canadian history.
On February 20th, 1959, the Avro Aero program was canceled. That was the end of the most advanced jet fighter of its day, a plane that had become a national symbol of Canadian excellence. 4,000 Avro employees lost their jobs. This meant one thing to the administrators of an ambitious new program in the United States. Highly qualified aerospace engineers could now be recruited to help them put a man in space. One of those engineers was Bryan Erb, now with the Canadian Space Agency. He works out of the Johnson Space Center in Houston, very close to some of his handiwork, the heat protection systems on the Apollo command module. He remembers being approached with the idea by Avro management.
Gee, this is a marvelous opportunity. At the time, I think I was just very grateful to have employment because I had two young children, a daughter who was only 10 weeks old, and it was rather important to get earning money again after the demise of the Aero project on Black Friday.
Another engineer who was approached by the company was Bruce Aikenhead.
Because of the work I'd been doing in flight simulators, I was assigned to the human factors section, specializing in training aids, my job was to work on the design and procurement of a procedures trainer that would be essentially a flight simulator for the Mercury capsule.
Owen Maynard was hired to make recommendations on the design of the Mercury spacecraft.
I wasn't a rocket scientist, I was an aerospace technologist. That was the function that I got hired in. That's like getting hired in as a flight sergeant or a second lieutenant or something into the Army or the Air Force or whatever.
They were 3 of about 30 Avro engineers working on Mercury. With the success of that program came the expansion of NASA. They were setting up permanent headquarters in Houston and calling on the Canadians to head to Texas. Some were reluctant to go. Bruce Aikenhead lined up a job in Montreal and returned to Canada, unfortunately just before John Glenn's historic flight at the end of February 1962. But the move worked out for Bruce. He eventually worked on the Canadarm and was in charge of the Canadian astronaut program at its inception. Because of his contributions, he was given the Order of Canada. Back in Houston, Owen Maynard moved on to the Apollo project, eventually accepting the job of chief engineer for NASA after the tragic fire that killed 3 astronauts during training for Apollo 1. Despite the fire, the dream of putting a man on the moon remained. Canadians continued to make major contributions to one of the most spectacular successes in human achievement. Bryan Erb became the deputy manager of a quarantine area for the Apollo 11 astronauts and the moon rocks when they returned to Earth. Neil Armstrong's first steps on the moon were particularly emotional for him.
That's one small step for man, one giant leap for mankind.
I sort of sprung and bought color television for the first time so that we could watch the events. And we had a party at our house and we were watching as all this was unfolding. And I can recall after they got out on the moon and they were cavorting around and having a great time, having fun jumping in 1/6 gravity, we were saying to someone, quit jumping around and pick up the rocks. I was rather anxious to see them get on with the geological aspects of the job because that was what was my bread and butter, because I wanted to see those lunar rocks come back to the laboratory that I was involved with.
As for Owen Maynard, he's not sure where he was when Neil Armstrong first walked on the moon, but his son tells him he was in bed. The landing wasn't on Owen's shift, and he had to work early the next day.
The landing on the moon was not a big deal, relatively speaking. The getting of them home back safely, the recovery, we had to have at least 2 of the 3 parachutes work, and a whole lot of other things work and we had to lift off from the moon yet. We've never done that before. So there's the parts of the mission that we had the least experience with were yet ahead of us.
Both Owen and Bryan saw the astronauts return home, but Owen stayed for just 1 more moon landing, and Bryan through the mission following that, Apollo 13. By the time man walked on the moon for the last time, they were working in private industry. The work they and their Canadian co-workers did was appreciated by NASA officials and opened their eyes to new possibilities.
I think one of the heritages of having that group come and work here is that it helped facilitate our international cooperation activities.
And I think all of us would like to think that we'd made a contribution, but it was not, I would say, not a dominant contribution. And I'm sure that the United States would have managed to put a man on the moon without us. But nonetheless, it was nice to be involved, and I think we played a significant role.
I think that there's a sense and an understanding that the Canadians have that, yeah, we can go out in the real world, we can go out in the world, we can go out and operate in the world stage, and we have no reason to be embarrassed about anything that our ancestors and predecessors have done, pretty much, and that Apollo is among that. I think that's, maybe that doesn't sound very heritageous to you, but that seems to me to be what's the essence of it.
When we come back, we'll look to the future to see the next step in Canada's adventure in space.
Hi, I'm Jay Ingram.
And I'm Jill Deacon. We hope you're enjoying the Discovery Channel's look at Canada's history in space.
Now, if you want to get the latest information about Canadians in space or about the International Space Station, all you have to do is watch at Discovery Canada.
We're on from Monday through Friday at 7 p.m. and 11 p.m. Eastern Time.
You might even learn a thing or two about some other Canadian science, too.
That is all for us. We're going to hand the reins back to Chris and the rest of the show. Chris is doing a very fine job, I think.
For an astronaut.
As you've seen, Canada has had an exciting history in space, and we're heading for a more exciting future. We're launching more satellites, and we're sending more Canadians into space. We're also on the threshold of being a major player in the most technologically complicated project ever, the construction of the International Space Station.
Canada is contributing an essential element to the space station, the mobile servicing system.
The International Space Station will be assembled. It started already in the November and December of last year, in those months, and it will take another 45 flights to bring all of the components together. The arm from Flight 6A, from the 6th flight essentially, will be on station and will be used to assemble all of the elements of the International Space Station, essentially taking elements from the cargo bay of the shuttle and attaching those components to the space station.
We have an inline critical role with our technology. The space station cannot be built without the Canadian contribution. That's not the case with some of the other nations. Those are add-ons to the station. Ours is essential.
Eventually, every astronaut who will live on the space station will have to know how to use the mobile servicing system. That means they will have to come through the Canadian Space Agency headquarters for training. A simulation room has been established to walk them through the learning process. There's a mock-up of the space station operations area so they can become familiar with the controls.
I'm going to rotate in for another capture.
All right, we got the trigger hot now.
Okay.
Bugs are crawling for you.
A virtual reality element gives them a different perspective.
Here I'm showing you.
Canada is also required to provide technical support for MSS, so facilities beyond the simulation center had to be established.
It consists essentially of a control room, very similar to the room that people are familiar with, you know, the famous control room in Houston. So we have a similar room with equipment that's fully compatible with the Houston, and we will be supporting the operations from the agency here.
Canadian astronauts will also be working on station construction. Julie Payette makes her first trip to space in May, and she's in Houston training. Julie will use the arm to assist her crewmates during spacewalks, and they will also transfer supplies to the existing modules of the space station, Zarya and Unity. Marc Garneau is scheduled to make his third trip into space in early 2000. His crew will be installing solar panels to supply the station with energy. I'll be going up later next year.
The next 5 flights associated with the assembly of the space station, there are going to be 3 Canadian astronauts. And again, this shows another dimension of Canada's contribution to this program. The United States didn't choose those 3 astronauts because they wanted to be nice to Canada. The United States chose those 3 astronauts because they're the best to do the job that has to be done. And so, as a Canadian, I feel very proud of the fact that Canadians are playing such a significant role in this absolutely major undertaking of humanity.
Canadian astronauts will also be on call to serve as station crew members. These contributions allow us to use the space station for Canadian science projects. We will get the benefit of the largest microgravity laboratory ever, basically a university floating in space. The space station not only represents a brave new enterprise for Canadians, but our partnership with the United States, Russia, Brazil, Japan, and the European Space Agency is a landmark event in international cooperation.
think about it, it's not too long ago that we were fighting each other and having wars, but now we are working very carefully, very closely together and accomplishing something that we couldn't do as individuals. That's very important.
My shuttle mission will take place sometime in the middle of next year. My flight will have a distinctly Canadian flavor. I'll be the first Canadian ever to go on a spacewalk, one of our more dangerous and difficult jobs, and during my spacewalks, 2 generations of Canadian technology will be bridged. I'll be standing on the end of the Canadarm while installing the new mobile servicing system onto the space station. It's important to remember that we're still leaving fresh footprints on the shore of our evolution in space. Only about 350 people have ever left the planet, and just 7 have been Canadian. The construction of the station and every trip in the shuttle is a pioneering experience, and that's why we're taking time out here to celebrate the 10th anniversary of the Canadian Space Agency on March 1st. We hope you've enjoyed a look back on the map of its accomplishments and its path to the future. I'm Chris Hadfield. Thanks for watching.